So have you ever thought about this? Can you actually grow a new bone inside your own body? Like on command. It sounds like something straight out of science fiction, right? But it's totally real, and today we're going to dive into the incredible living architecture of our skeletons to see exactly how it works.
Okay, so let's start with a story. This is about Penny. And for her, this 5 centimeter difference in her leg bones, well, it wasn't just some number on a chart. It created this whole cascade of other problems. We're talking a curved spine, scoliosis, and this chronic, awful pain that just doesn't go away. So you can imagine, her situation posed a huge question for her surgeons.
I mean, seriously, just stop and think about that for a second. How on earth do you get a human body to build 5 centimeters of brand new, solid bone? Pretty much out of thin air. It sounds completely impossible, doesn't it? But here's the thing. The answer, the secret, is already hidden inside us. It's in our body's own blueprint for healing itself.
So let's get into it. How do surgeons pull this off? The secret? Well, it's not some brand new high-tech invention. It's actually all about understanding something our bodies already do perfectly. It's about tapping into that natural healing process. That's the key to the whole thing.
Okay, so this is where things get really interesting, because it kind of flips what you think happens when you break a bone. You'd assume your body just, glues the two broken pieces back together, right? Nope. It actually starts a massive construction project. It builds a whole new bridge of bone right across that gap.
And the star of this construction show is something called a fracture callus. And really the best way to think of it is as this soft, jelly-like blob of new tissue. This blob shows up right at the break and is basically a living scaffold, a framework that the body uses to start building.
Yeah, it's like the body has its own biological 3D printer. It uses that callus as the blueprint and just starts printing new bone cells layer by layer right onto that scaffold. It keeps going until the whole gap is filled and the bone is solid again. So here's the big takeaway. Our bodies already know how to build bone from scratch. That's the secret.
Okay, so if our bodies can already do this, that opens up a really cool idea, right? A medical what if. What if you could hijack that natural process? What if you could control it? And that's exactly where the clever part comes in. And this is the genius hack. Instead of waiting for a random break from, falling off your bike, surgeons create a very precise, controlled break, on purpose. Then they can manipulate that gap to trick the body's healing system to kick it into overdrive. And the body isn't just building a small bridge anymore, it's tricked into building a whole new section of bone. So the official name for this is distraction osteogenesis. Sounds complicated, but it's basically these 4 steps. First, the surgeon makes that clean break. Second, they attach this metal device called a fixator. Then, and this is the key part, that device starts to slowly, and I mean very slowly, pull the 2 ends of the bone apart. And because the gap keeps getting bigger, the body is constantly fooled into filling that space with new bone.
So just how slow are we talking? 1 millimeter. A day. That's it. Think about the thickness of a credit card. That's how much they separate the bone each day. If you go any faster, the whole process just fails. Go any slower, and the bone heals too quickly. It's that unbelievable precision that makes the whole thing possible.
And this all comes back to our friend, the fracture callus. That 1 millimeter stretch is the perfect signal to the body. It's like saying, hey, keep making that jelly-like blob right here. The body just keeps trying to close the gap, and as it lays down new jelly, the older stuff at the back starts to harden into real, solid bone. It is an absolutely brilliant hack of a natural system. But there's a catch.
So you get perfect brand new bone. Amazing, right? But here's the thing we haven't talked about. A bone doesn't just float in your body by itself. And that simple fact, well, that's where we find the hidden and frankly really challenging complication in this whole story.
Just think about it for a sec. You grow a bone by 5 centimeters. Great. But what about everything else that's attached to it? Your muscles, your nerves, all your blood vessels. They have to cross that new distance too. And this right here is where we bump up against a really big biological wall.
And this is the absolute crucial difference. Remember how the body can print new bone cells? Well, it can't do that for muscles and nerves. Those cells are different. They're super specialized. They can't just divide and multiply to fill in a gap. So for all that soft tissue, the muscles, the nerves, there's only one option. The existing tissue has to physically stretch. And the consequences of that stretching, they are no joke. We're talking about immense tension on all that soft tissue. This is what can lead to really serious chronic nerve pain. It's the single biggest risk and challenge of the whole procedure. It's a hard limit of our own biology, and getting through it means months or even years of grueling physical therapy just to help those tissues adapt.
So you see the trade-off, right? On one hand, you have this incredibly powerful solution, a way to literally build new pieces of your own skeleton. But on the other hand, it only works by pushing everything around the bone to its absolute breaking point.
Which brings us to a pretty deep final thought. Being able to grow bone like this is, no question, a huge triumph of medical ingenuity. But it's also a pretty humbling reminder, isn't it? That even when we find these clever ways to hack our own biology, we're still playing by its fundamental rules. And it makes you wonder, what other biological limits are out there, just waiting for us to find them?